Okay, this is a preview of an Android app I've been working on called Bitcoin Authenticator. It's designed for two-factor authentication for Bitcoin wallets. This is a projection of my actual phone here. It's not an emulator, so there's going to be a little bit of lag. Little background of this project. If you're unfamiliar with two-factor authentication, the way a typical Bitcoin wallet works is for every address in your wallet you have a single private key, and that key is needed to sign transactions to spend the funds in those addresses. And those keys are kept in a data file on your computer, which means if your computer is hacked, well then you lose all your Bitcoins. With two-factor authentication or a wallet with two-factor, what we're essentially doing is we're creating what's called a multi-signature address. This is a Bitcoin address that has more than one private key and requires multiple keys to sign the transaction to spend the funds from those addresses. And typically what you'll do is you'll keep one key or set of keys on your computer, and you'll keep the other set of keys somewhere else. And the services that people are currently creating for this are typically web wallets, where you control one set of keys and the second set of keys are kept on a trusted server run by a third party. And whenever you want to make a transaction, the wallet signs it with your key and then forwards a transaction over to this server, and the server signs it with its key and broadcasts it to the network. And what that means is if your computer gets hacked, your Bitcoin coins can't be stolen because the attacker would only get one of the 2 or 3 keys they would need to actually spend the Bitcoins. So this represents a pretty significant advance in wallet security. Unfortunately, the beef I have with this model is that you're basically sacrificing your financial privacy for security, right? So the server run by this third party can see all of your transactions. You're sending all of your transactions to a third party, and you have to worry about them potentially keeping logs. And even if you connect to the server through Tor to try and hide your IP address, the server still retains the ability. It necessarily has to retain the ability to associate addresses with wallets. It can't authenticate you if it doesn't have that ability. And so what that means is if anyone with access to the server can link your identity to even a single transaction, well then your entire transaction history can be de-anonymized. And in this day and age, we don't just have to worry about, say, government subpoenas. We know that the NSA actively forces companies to give them backdoors into their systems. I mean, just look at like Ladar Levinson at LavaBit. The NSA was demanding his SSL key so they could run man-in-the-middle attacks on his servers and record all the data coming to and from his server. And given the nature of Bitcoin, you can certainly expect that this is something the NSA would be interested in doing for these services that see all of your transactions. So what we're doing here with Bitcoin Authenticator is we're taking your second set of keys off of a trusted server and moving it onto your smartphone. So you are the only one who sees all of your transactions, you control all of your keys, and the transactions are sent between your wallet and your mobile device, and that's it. And this has an added benefit of you're not stuck using whatever web wallet they've created to go with their services. Theoretically, this authenticator could work with any Bitcoin wallet out there, so long as the developers are willing to support a plugin for it. And even if not, we could just fork the software and add the plugin itself. So let's take this for a little bit of a test drive. When you first start it up, it's going to display a seed. This is uses BIP39 to generate a seed for this device. This is mnemonic encoded. You're going to write it down, keep it in a safe location. All of the keys that are generated on this device are going to be derived from this seed here, so you can use this to recover it if you have to at a later date. Okay, so we hit continue. Now we have to pair this with a wallet, and if you're familiar with Google Authenticator, if you've ever used that, you know the way you pair Google Authenticator with a service is the service generates a random 80-bit key, displays it to you in a QR code, and you scan that, and essentially establishing a shared secret between the server and your mobile device. What we're doing is something similar. We're going to generate a 256-bit AES key, but in addition to that, we have to set up a peer-to-peer connection between the mobile device and the wallet. Okay, so we're going to connect over a TCP socket, and then we're going to encrypt it with that shared secret. So I've set up a little test wallet here just to demonstrate this. Okay, so I'm just going to enter a name here for, I'll call it test wallet. Okay, and over here I'm going to hit pair wallet. Normally you would, if this were an actual wallet with a GUI, this would probably be in the settings somewhere. And I've included a couple logos for some of the more popular wallets in case the developers want to support it. Their logo will show up in the list view. We'll just use blockchain as an example. Okay, so what's going on here in the background is the wallet is using universal plug and play to map port, connect to my router and map port. I'm just using port 1234 for testing. This is so the user doesn't have to set up port forwarding in order to take incoming connections. Okay, and then the data that's being displayed here in the QR code is this is a randomly generated AES key along with the IP address for my this is my laptop, and then this is my local IP on my network, the 192.168.1.4. Both of these are going to get passed over to the authenticator, and the authenticator is going to have to decide, it's going to have to figure out if it's on the same Wi-Fi network as the wallet. If it is, it'll use this IP address to connect. If not, it'll use this one. I'm on the 4G, so it'll use my public IP. Okay, so I'm just going to scan this. Oops. Okay, so what it did there after it scanned the QR code was it connected to the wallet, so we can see we're connected to Alice now. And it sent over, well, first it derived a new master public private key pair for this wallet. So every wallet you pair with this authenticator, it's going to derive a new key pair from that seed, and it sent over the master public key over to the wallet. Now, when it sent it over, it was encrypted with AES, and we also included a message authentication code. It was HMAC SHA-256, so we can authenticate that there was no man in the middle on that connection. And now what I'm going to do, I'm going to create a new address. Okay, so what this has done is it's deriving a new child public key from this master public key. This is using BIP32, and so the authenticator has it can derive the corresponding private key for this child key here, and then it's generating a new key pair that's stored inside this wallet, and it's using these two public keys to create a script, and then this is the pay to script hash address which we are going to use. So to demonstrate this, I'm going to send some bitcoins over to that address. This is Electrum here. We'll just send 1 millibitcoin. Okay, so there we go, it's sent. So now essentially what we've done here is we've sent bitcoins from Electrum, broadcasted to the Bitcoin network, and it's received by this wallet over here. Now we're just going to send them back, and I'm going to show you how we're going to do that because, again, the keys are split between the two devices. So I'm just going to, we're going to make a transaction from, we're going to send it out of that multi-sig address we created to, we're going to send it back over to an address from Electrum. And the amount, we'll just send 90,000 Satoshi. We'll leave 10,000 for the transaction fee. Okay, and this is our unsigned transaction. This is what's going to be sent over to the authenticator. And at this point, we would just hit send. Now, when I hit enter, this would kind of be the equivalent, if we had a GUI, this would be the equivalent of the user clicking send on their wallet, and this is what would happen, right? So I hit send, and it pops up over here on the authenticator telling me that a transaction was just made sending coins out of our test wallet to this address over here, and for 0.009 Bitcoin, and it's asking me if I want to authorize it or not. Now, I'm probably going to make it so that you can go in the settings menu. By default, this will automatically ask you to authorize all transactions, but you can go into the settings menu and tell it, you know, that to automatically approve transactions like below a certain amount, or maybe if you got a signed payment request from like BitPay, to automatically authorize it. But by default, it's always going to ask you to authorize it. But that's something I still have yet to implement. So when I hit authorize, here's what happens. It signs a transaction, sends it back over to the wallet, and the wallet receives it. Here's a signature, builds a transaction, broadcasts it to the network, success, and you can see Electrum is telling me we just received a new transaction. Okay, and there it is. So the coins were sent back into Electrum. And this is our transaction ID, which should match, if I check this. Yeah, the IDs match. Okay, so there it is. I still have a good amount of work to do on this. One of the main things I still have yet to do is I want to create a server for this. Right now, the authenticator tries to connect to the wallet using the last known IP address. And that most of the time that works fine, but if your IP address changes, the authenticator won't be able to connect. Now, you can always reconnect just by repairing. That works just fine, but it's a little inconvenient. So I'm going to make a server just to facilitate the peer-to-peer connection, so the authenticator can get the IP from the wallet from the server. And if I do it right, the server won't even learn of your IP addresses. But all transactions are always going to be sent peer-to-peer. They're not going to be forwarded to the server or what have you. And then finally, I would like to release this, have at least one wallet support this authenticator when I release it. And if there aren't any developers willing to incorporate a plugin for it initially, I'll probably just fork an existing wallet and release it. It'll probably be multi-bit. But that's it for now. That's Bitcoin Authenticator. I would appreciate your feedback. Let me know what you guys think.